Hello grade 11s. We are on video number 3 of the vectors in 2 dimension. On the previous video we are calculating the magnitude of resultant and the direction using trig ratios. Okay, remember that you are going to use the trig ratios only if you are getting the right angled triangle. Okay, if you have the right angle triangle, then you can use the trig ratios. That is the right angled triangle. Right angled triangle is having 90 degrees somewhere. So we have this side which is the opposite of this angle. Then this is the adjacent side of this angle. Then this one is hypotenuse side. Then we use the trig ratios to get the direction. Now we are going to explain the meaning of a closed vector diagram. The closed vector diagram can be a right angle triangle, or can be just any other triangle. Okay, all right, so we are going to explain that. Then we resolve vectors into its vertical component and horizontal components. Okay, let's start with a closed vector diagram. So a closed vector diagram is the set of vectors that are drawn such that the resultant of the resultant is 0. That is, f res in a closed diagram will be equal to 0 newtons. Okay, the example of a closed vector diagram is sometimes when you have, for example, something that is hanged. Let's say you have the object here that is pulled in this direction. Let's say this is 2 kg, and here we have the angle, for example, let's say 10. Okay, so you have 3 forces here. You have this force that is applied, then you have the weight of this object. Then if they say this object is not moving, you can draw a closed vector diagram, because when the object is not moving, f res is equal to 0, which means the forces are balanced. Okay, so the forces are balanced. Forces are balanced. Okay, that is why we say you can use the closed vector diagram. So we use the tail to head method. So remember that this tension is up, so we have a tension here, the force on a string. So you can just draw a closed vector diagram using this. So you have the force that is directed in this direction, that is force applied. Then we have the force that is directed in this direction, that is what the tension. Then we have a force that is directed downwards, that is what the weight, that is Fg. So this is the closed vector diagram. Closed vector diagram, you have these angles that you need to work on. So if we can draw a line that is vertical, remember Fg is vertical, so we need this angle. This angle is 80 degrees, which means the angle between a vertical force and T, vertical force and T, is 80. So we have 80 here. So let's say this one is 90, so we have 90 here. So if it's 9, this one is 10, to make 108. The sum of angles of a triangle is equal to 180. This is a closed vector diagram where the forces, the set of forces, will give you f res, which is equal to 0. So you can use trig ratios because there is this 90, and you can also use the sine rule. Sine rule, sine of angle A divided by small letter a is equal to sine of angle B divided by small letter b. Okay, so we are going to do that. We will have a video on that. Now let's resolve the components. Let's resolve the components. Okay, so when we resolve components, you must know that we have two components. Okay, you have the horizontal component and a vertical component. Remember that on a Cartesian plane we have only x and y. But if you are given the force that doesn't have x and y, you have to resolve the components. I will just give you the formula. To resolve fx, you are going to use a force cos theta. So this force is slanted, is a slanted force. Then this angle is the angle between this force and x-axis. Then you are going to resolve a y component, that is vertical component, by using this formula. This force is that slanted force. This angle is the angle between this force and x-axis. So let's have an example. If, for example, you are given forces on a Cartesian plane, let me just say we have 2, 4, 2, 4, 6. Okay, then we have -2, -4, -6, for example, -2, -4, -6. Okay, remember we were dealing with the forces that are on the axis, that is y-axis and x-axis. But in this case, you are given the force that is between x-axis and y-axis that acts on an object. They say this one is force 1. Force 1. Let's say this one is 2 newtons in this direction, as you can see. Then they give you another force. Let's say this force is in this direction. They say this one is force 2. Force 2, which is maybe 3 newtons. Then the angle is given. Let's say this angle is, for example, is 30 degrees. And this angle, let's say, is 15 degrees. Now the question says calculate the resultant force. The first thing that we need to do is to resolve the components. Okay, we are going to resolve the components. Let's start with fx. We have two forces, which means we are going to have two x forces. Okay, that is fx. So we are going to resolve components. This one, this force, is in this quadrant. And here there are negative x and negative y, which means we are going to have the force here, which is our fx. Okay, this angle is 30 here, 30 degrees. So we'll have fx here, Fx for force 2, this force. Okay, then we are going to have another force which is Fy. Okay, then for this one is on first quadrant. First quadrant is between positive y and positive x, which means we're going to have a force in this direction. We're not sure the magnitude of this force, but this is Fy 1, or this one is Fy 2 because it's from these two. Then we have another one here. We're not sure about the magnitude, but it's Fx 1 because it's from F1. So we are going to calculate these forces. These are the components. These are the vertical component and horizontal component. So let's start with vertical components. Okay, let's start with vertical and horizontal. Let's start with horizontal component. I said this is the formula. But the focus now is on 1, that is x1, which means I'm going to use this and this angle. So the angle that is slanted is 2. Then cos the angle is 15 degrees. The force that is slanted is 2. Then the angle there is 15. Then we press the calculator. So we get 1,93 newtons. Then since it is directed in this direction, that is right. Then we are going to look for Fy 1, which means we're still here. This is Fy 1. So it's F1, that was F1, but sine theta now. So the force is 2. Sine the angle is 15 degrees. Then we press calculator. So we get 0.52. 0.52 newtons. The arrow is up, so we can just say upwards. Fy 1. This is Fx 1. So we have resolved the components for this one. We resolved the components of this one. Now we are on this one. Same applies here. We have Fx for 2 now will be F2 cos theta. Fx2, the force is 3. Cos the angle here is 30. Then we press calculator. 3 cos 30. 3 cos 30 is 2,6. So it's 2,60 newtons. The direction is for this one to the left. Then that is Fx2. Then we go to Fy2. It will be F2 sine theta. This is F2. So it's 3 sine 30. 3 sine 30 supposed to be 1,5. 3 sine 30 to 1,5 newtons. The direction is downwards. That is Fy2. This is how we resolve the components. Then you are going to answer the questions based on the components. So we have the x component for force 1, the x component for force 2, right? The y component for force 1, the y component for force 2. Then you are going to choose the direction, then you combine them you represent them on a Cartesian plane, that is neat. Then you calculate the resultant force. Okay, so that is how we do it. We use Fx, that is horizontal component, that is F cos theta. Then we use Fy, that is F sine theta. Okay, then we are going to use the angle. The angle, make sure that the angle is between the x-axis. So these are the y-axis, these are the x-axis. The angle must always be between the x-axis and the force. This is the force. Let's say the angle is given here as 30. This is not the angle that we use. We use the angle that is between x-axis and what? And the force, which means you must determine this angle. So we know that this one is 90 degrees. Y-axis are perpendicular to x-axis, which means the angle here is 90. If we have 30 here, which means here is 60. So you are going to write 60 here and use 60, not that 30. 60. Okay, so we are done. Thank you very much. Thank you. So we use this formula and this formula. This is the horizontal component x, this is the vertical component y. Then we are done. Thank you. Don't forget to subscribe.